Hi and welcome to another video for Additional Maths Year 9 under Chapter 8 series. So this time we are going to deal with another type of progression which is called geometric progression. So for this one you also need to focus on how to find the nth term, which is the n will be the unknown, and also you will use the formula to find the sum of the first n terms. So over here, quite similar to the concept for the arithmetic progression, geometric progression also will use formulas. So formula is given over here. So I hope from last lesson you knew what's the meaning of the individual letters in the formula. So for the first one, un equals to ar to the power of n minus 1. This is for the individual terms, and the second formula would be the sum of the nth terms. So sum of the first n terms is over here, a bracket 1 minus r to the power of n over 1 minus r, or it will be the second one. So the second one over here is a bracket r to the power of n minus 1 bracket over r minus 1. So these two has the individual conditions to use this term. So it is going to be related to the r. So the new term for this one will be r. So r over here, we call it as the common ratio. So let's have a look at the explanation over here. A geometric progression is a sequence in which each term is multiplied. So here multiplied from the term before by a constant, which is known as the common ratio. Common ratio will have r as the notation in the formula. So for example over here, if we have a look at these numbers, 7 into 14, and the next term is 28, 56, and 112. So here, it is quite obvious that the rule that you will use for this is multiply with 2. Because here 7 times 2 is 14, and 14 times 2 is 28. So here consistently, this is your 2. So the common ratio is a 2. Right? So the r is a 2. The first 5 terms of a geometric progression whose first terms is a and whose common ratio is r. So here you can see the difference between the first term and the second term will be multiply with r. So here I can see here the power of r in the second term is power 1, and multiply with another r will get we will get r to the power of 2, r to the power of 3, and so on. So this one leads to the formula nth term, which is un equals to ar to the power of n minus 1. So here just to recap back on the letter u. So if you're dealing with the first term a, it is also the notation for this one will be u1, u2, u3, and so on. Right, so let's have a look at the example. So the first example over here, the third term of a geometric progression is 144. So here 144 is the u3 because it's the third term. And the common ratio over here is 3 over 2. So it's possible to have a fractional common ratio. The question over here is find the seventh term. So here you're looking for the seventh term. So let's have a look at the formula that we will use. u7 equals to ar to the power of n minus 1. So from here, you have the common ratio already, but the missing term is the term that we will use for the first term. So let's use this information to find the a. So u3 is 144, 144 equals to ar to the power of n minus 1. So a is the number that we're looking for, r is the common ratio, 3 over 2, put inside the bracket, and n for this one is a 3. So 3 minus 1 is a square. So as simple as that. So here 144 equals to 3 over 2 squared would be 9 over 4, and next to it will be a. So here it's obvious that you have to move the 9 over 4 to the other side. So it will involve a division. So what we're going to do now is division of 9 over 4. means multiplication of its reciprocal, which is 4 out of 9. So then here A equals to, let's check using our calculator. So 144 times 4 over 9, it will be a 64. So your first term is 64. So there we have it for the first term. So let's focus on looking for the seventh term. So the seventh term, we'll use this formula also. Un equals to ar to the power of n minus 1. So let's begin. Un, your n is 7, equals to a 64 times the common ratio, which is 3 over 2 to the power of n minus 1. So n minus 1 is 7 minus 1. So this one is a direct calculation of 64 times 3 to the power of 2 to the power of 6. So this one, if we use our calculator, 64 bracket 3 over 2 and close the bracket, give the power of 6, you will get 729. So therefore, this is the seventh term, which is 729. Right, so that's for the first example. In the next page over here, this is the next example. Okay, for this one, the second and the fourth term in the geometric progression are 108 and 48 respectively. So here, as far as we know, 108 is a U2 and 48 is a U4. So the question is, given that all the terms are positive, right, so if the terms are positive, all the terms are positive, find the first term and the common ratio. Right, so here the missing term is A and also R. So with that, we're going to use the above formula, which is Un equals to AR to the power of n minus 1. So here, starting with our second term, which is 108, it is equal to AR, which is the missing term, n minus 1. So n minus 1 is 2 minus 1, so AR to the power of 1. So this one, okay, let's let it be this equation first, and let's have a look at the fourth term. The fourth term is 48. It is equal to AR to the power of n minus 1, which is 4 minus 1, AR to the power of 3. So this one is quite obvious that we have to solve this simultaneously. So say we will look for the common ratio first. Alright, so if you want to look at the common ratio, we change the first equation subjects into A. So A equals to 108 over R. So this is the first equation. And as for the second one, is this formula, is this equation. So this one is the second formula. So here what are we going to do is substitute equation number 1 into equation number 2. So equation number 1 is an A as the subject, so you have to replace A in your second equation. So let's proceed. 48 equals to 108 over R, and next to it will be an R cubed. So here, simplifying the equations, so 48 equals to, this one can be simplified by dividing R cubed with R. You will get R squared. So you have 108 R squared. So this one, R squared, can be obtained by moving it to the other side. So this one will be by division of 108. So your R squared would be 48 over 108. You will get over here 4 out of 9. So 4 out of 9 is the R squared. So the final step will be here, because we want to find the common ratio R, you have to apply square root. So by right, if you have a square root on a number, there will be a plus minus. because the square of both the positive and negative numbers will get you a positive number. But in this case, since it's already mentioned that all the terms are positive, so therefore your R must be a positive number. So R is a positive 4 out of 9. Right, so it's this only for R, 4 out of 9. So let's look for A, which is the first term. So the first term over here, you can use the first equation, and all you need to do is just substitute R equals to 4 out of 9. So here, if we write down A equals to 108 over R, we substitute R equals to 4 out of 9. So over here, A equals to 108 divided by a fraction of 4 out of 9. So this one, if we use calculator, therefore, A is 108. Okay, 108 over another fraction, 4 out of 9, which means 108 divided by 4 out of 9 will give you 243. So these are all the required questions. You answered. The first term is 243, and the common ratio R is positive 4 out of 9. Alright, so let's move on to the next aspects of geometric progression, that is about the sum. So the sum of a geometric progression, which is denoted by Sn, there are two formulas for it, but here there are several conditions. Okay, so in the first formula, A bracket 1 minus R to the power of n over 1 minus R, this is when you have the common ratio between -1 and +1. So in a way, it's a positive fraction, so to say, a positive proper fraction. And as for the second one, A bracket R to the power of n minus 1 over R minus 1 is the opposite of the first formula. So the second formula, you can use it when R is more than 1 or R is less than -1. So here you have to remember at least the second condition, as this one will not be given in the exam. Only 1 minus R will be given. Okay, only the formula with the 1 minus R will be given in the exam. So when you have to look carefully at the common ratio that you have. Okay, so let's use apply the formula for several examples. Okay, the next one. Find the sum of the first 10 terms. Okay, so this one requires you to find S10 of the geometric series 2 plus 6 plus 18 plus 54. So these are all the terms. Alright, so here, if you can see, 2 is your A, which is your first term. And as for the common ratio R, you can obtain it by dividing two consecutive terms together. For example, here you can divide 6 divided by 2, or you can divide 18 by 6. So here, it's quite obvious that the common ratio is a positive 3. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. So, this one, you can straight away apply this formula. Since the R is more than 1, so you are using the second formula, which is A bracket R to the power of n minus 1 over R minus 1. So here, let's begin. S10 equals to, A is a 2, bracket, R is a 3 to the power of n, and over here is a 10, everything minus 1, over R minus 1 will be 3 minus 1. So this one is a direct calculation. You can use a calculator. Right, so here, let me have a look here. Form a fraction 2 bracket 3 to the power of 10 minus 1 over 3 minus 1. So this one will give you 59,048. 59048. So that's for the third example. Right, so let's have a look at the last example for this subtopic. So here you have a question, quite lengthy over here, but you have to read it carefully. Okay, the second term of a geometric progression, which is u2, is 9 less than the first term. So first term is u1, or which is an a. So here 9 less than the first term means it is going to be the first term subtracted with 9. Less than means reduce. So reduction means subtraction. So if you want to form the formula for this one, you can give it as u2 equals to u1 minus 9. And then as for the second term, second condition is the sum of the second and the third term is 30. So here it involves u2 and u3. So the formula over here, you can form u1 plus u3, u2 plus u3 equals to 30. So given that all the terms in the progression are positive, so it's quite a big hint towards the common ratio over here. So the ratio must be a positive number. So given that all the terms in progression are positive, find the first term, which is your u1, which is an a. Alright, so here you are supposed to use the formula for this one only, which is a r to the power of n minus 1. So let's begin. As for the first equation, let me write down number 1. So number 1 over here, u2 means ar to the power of n minus 1. N minus 1 is 2 minus 1 is just power 1. Let it be just r equals to a minus 9. Because u1 is obviously an a minus 9. So for this one, let's say we make a as subject. Okay, we make a as subject. So which means this a must be moved to the left side. So ar minus a equals to negative 9. So we have to factorize a over here. Take out a and let the rest of them inside the bracket equals to negative 9. So this one, if we divide both sides by r minus 1, you will get a equals to 9 over r minus 1. So this one, we can actually turn the negative 9 into positive 9. But here, we will multiply this by negative 1 and also this one. So we change all the signs in the term. So you will have positive 9 equals to negative r plus 1. Or you can write down 1 minus r. Right, so let this be the first equation. And as for the second equation, let's form the formula or equation. u2 is ar to the power of n minus 1. 2 minus 1 is just still 1. r to the power of 1 plus ar to the power of 3 minus 1 is a 2 equals to 30. So here, if we have a look at the equation, we can actually factorize ar. So here, ar is the common factor for both the terms here. ar plus 1 minus r equals to 30. So this one is your second equation. So this one is the first equation. So you can see here, the subject for the first equation is a, which is 9 over 1 minus r. So if you substitute this, we can solve for r. So here, let's have a look. If we substitute 1 into 2. So which means the a will be this one, 9 over 1 minus r. Okay, so this one, okay, we just write it down first. What do we have? So what do we have here? A is 9 over 1 minus r times r for the left side over here. So I will just write it down as 9 over 1 minus r, but next to it is a multiplication with r. So this one is the ar multiplied together. and next to it will be 1 plus r equals to 30. And here you can see, in order to solve this equation, the next step will be, it's easier to do not have a denominator, so we do not want a denominator over here, so multiply the whole equation with 1 minus r. So on the left side, the 1 minus r is cancelled, so 9r bracket 1 plus r, and then 1 over r is cancelled, equals to, on the right side is 30 bracket 1 minus r. So this one is quite easy to solve. Okay, so let's have a look if we expand this. So 9r plus 9r times r is 9r squared, equals to 30 times 1 is 30, minus 30 times r is 30r. So here it's quite predictable that this will be a quadratic equation with r as the unknown. So let's move the 30 minus 30r to the left side. Okay, arranging them all straight away. So you will have 9r squared, and 9r plus 30r is plus 39r. And the 30, you move to the other side, the left side will be minus 30, equals to, the right side is 0. So this one, okay, the tips, if you have common terms in an equation, you can just straight away divide all the terms with a number that is a common factor to this. Okay, the highest common factor to this equation will be a 3. So here 3r squared plus 39 divided by 3 is 13r, 30 divided by 3 is negative 10, equals to 0. So this quadratic equation with an r as unknown, this can be factorized by making them into double bracket. By making it into a double bracket, so over here 3r times r, and you have to multiply, factors of 10. Here it will be 2 and 5. So 15 minus 2. And coincidentally, negative 2 times 5 is negative 10. So this is the complete factorization, which will give you 2r values. So the first value over here is 2 over 3. And the second value will be a negative 5. So this one, since in the question, it says that all the terms in the progression are positive, so you have to use r as 2 over 3, not r equals to negative 5. So here, this is your r. Okay, for this particular r, you have to find the first term a. So in your first question, in the first equation, a equals to 9 over 1 minus r. So let's copy down a equals to 9 over 1 minus r. So we substitute r equals to 2 over 3. So this term will change into 2 over 3. So a equals to 9 over 1 minus 2 over 3, which will make this 9 over 1 over 3. So 9 divided by 1 over 3 will therefore give you 9 times 3, which is 27. So there you have it. This is the first term for this example. So with that, that's the end for this subtopic. I hope that it can help you filling in your notes. So with that, thank you very much and see you in the next video. Thank you.